Welcome back. So in this session we are going to discuss about equilibrium. What do you mean by a thermodynamic equilibrium? So equilibrium literally means a state of balance. So there are no unwanted potentials within the system concerned. That means there are no unbalanced potentials related to pressure or temperature or chemical. No such unbalanced thing. Everything is in a balanced condition. So equilibrium means it is a state of balance. You might have learned about this equilibrium in mechanics, physics, right? So when a body is lying on a flat surface, it is said to be in equilibrium. Or if it is in a curved surface, you know that it is having a tendency to move back and forth so that it will reach at a place where it will not move further. So similarly in thermodynamics there are different types of equilibrium like mechanical equilibrium, thermal equilibrium, chemical equilibrium and phase equilibrium. The first one, mechanical equilibrium, is established when there is no change in pressure within the system. Suppose there is a piston cylinder device, okay, and you are compressing the gas by applying a force on the piston. As we have seen in the previous class, in the fundamental terms, we have defined the state, right? So suppose you have a piston cylinder device and you are applying pressure on the piston so that the gas is getting compressed. So it will take some time to distribute the increase in pressure throughout the gas, throughout the fluid contained. But at some point, the pressure in each and every point within the system will be equal with respect to time. So that condition, that at that particular point, we can say that the system is in mechanical equilibrium. If there is some pressure difference, what will happen? There will be some flow, right? So there will be some movement of the molecules. So when that is ceased, that condition is called mechanical equilibrium, and that is related to the internal pressure within the system. Now coming to the second category of equilibrium, thermal equilibrium. It is related to thermal, temperature, right? Thermal means temperature. It is related to temperature. Suppose there is a hot coffee in a cup. Okay, you are pouring some hot fluid or coffee into a cup. Immediately, what will happen? The temperature of the hot coffee will not be felt on the surface, outer surface, isn't it? But as the time proceeds, slowly the heat transfer will be taking place. If the cup is open, if the cup of hot coffee is open, it will establish a thermal equilibrium within the cup. That means the temperature of the coffee will be equal throughout the system. Suppose initially it was at 50 degrees Celsius, at a later point of time it may reach even 35 or 30 if you give enough time for the thermal equilibrium to get established. So such a condition, when there is no heat transfer or the each and every point within the system experiences the same temperature, that is said to be in thermal equilibrium. Now coming to the chemical equilibrium, you know that in every substance there will be some chemical reaction taking place at the molecular level. When there is no such chemical reaction taking place at the molecular level, that is, the chemical composition of the substance of the system is same, or if the system is homogeneous, you can say that the system is in chemical equilibrium. So there are no chemical reactions, endothermic or exothermic or any such reactions will not be there in the case of this particular equilibrium, chemical equilibrium. Now coming to the fourth category, the last one, this is important only in the case of the substances which are situated in two phases. For example, ice cube floating in water. So when the mass of each phase reaches an equilibrium level and stays there, we can say that this mixture of the two phases of the same substance is in phase equilibrium. So this is important only when we are discussing about two phases. So the first three, mechanical, thermal and chemical equilibrium, are most commonly used in thermodynamics. This phase equilibrium will be discussed or considered only when there are two phases, two phase flow. Such things only will be considering this phase equilibrium. Otherwise, when the other three equilibriums are satisfied, we can say that the system is in thermodynamic equilibrium. If there are two phases involved, when all the four equilibrium conditions are satisfied, we can say that the system is in thermodynamic equilibrium. Now, based on this equilibrium condition, at the state of balance, when the change of the system taking place, one equilibrium condition to another equilibrium condition, you know that is known as a process. That is a process. Now, there could be different kinds of processes. Different kinds of processes, that is the intermediate states the system passes through, as in the case of process, may or may not be in equilibrium with respect to the surroundings. So we will see that in detail in the next session, quasi-static process. Okay, so till then, goodbye, stay tuned, learn, and if you have any doubts, please don't hesitate to drop in a comment in the chat box below. Till then, goodbye. Thank you.